Hello students, welcome to P Block Elements Lecture 3. Let us begin this lecture with chemical reactions of ammonia. Ammonia reacts with oxygen, forms dinitrogen and water as the product. When ammonia reacts with excess of oxygen, it is going to form oxide of nitrogen, that is nitrogen monoxide and water. This reaction is carried out in the presence of platinum as a catalyst and high temperature of 1100 Kelvin. Oxidation of ammonia. Ammonia undergoes oxidation in the presence of oxidizing agent like a cupric oxide and forms dinitrogen, water and copper as the product. Aqueous solution of ammonia is weakly basic due to ionization of OH- ions. Means when ammonia dissolved in water, it accepts a proton from the water and converted to ammonium ion, and water is converted to OH- ions. In other words, OH- ions are released in water, and we know anything that gives OH- ions in water is called as a base. So ammonia reacts with water and converted to ammonium ion, thereby forming hydroxide ions. And we know that anything that gives hydroxide ion is called as base. Ammonia undergoes self-ionization in its liquid state to form NH4 plus and NH2 minus ions. So here you can see to form NH4 plus and NH2 minus ions. Action of halogens. Reaction with chlorine. Ammonia reacts with chlorine and forms ammonium chloride as a product along with dinitrogen. So here we have taken excess of ammonia. Suppose when excess of chlorine is taken as a reactant, then we are going to get a nitrogen trichloride as the product along with hydrochloric acid. Reaction with bromine. When ammonia reacts with bromine, it forms ammonium bromide as the product along with dinitrogen gas. Reaction with iodine. Ammonia reacts with iodine and forms ammonium nitrogen triiodide. You can call that one as nitrogen triiodide ammonium, and hydrogen iodide as the product. This nitrogen triiodide ammonia is unstable, decomposes to give nitrogen, iodine and ammonium iodide as the final product. Reaction with metals. Sodium metal reacts with ammonia and forms sodamide as a product along with dihydrogen as a gas. This reaction is carried out at a temperature of 575 Kelvin. When ammonia reacts with sodium hypochlorite in the presence of gelatin as a catalyst, it forms hydrazine as a product along with sodium chloride and water. Reaction of ammonia with the white precipitate of silver chloride. Silver chloride reacts with ammonia and forms a soluble complex of diamine silver 1 chloride. So here we have white precipitate of silver chloride. When we add ammonia drop wise, you can see there is a solubility of silver chloride due to the formation of the complex diamine silver 1 chloride. Reaction of ammonia with the copper sulfate. When ammonia reacts with the copper sulfate, it forms a dark green colored complex tetraamine copper 2 sulfate. You can see here, when we add ammonia, there is a formation of dark green colored tetraamine copper 2 sulfate as the product. These reactions prove ammonia behave as a ligand. Reaction of ammonia on Nessler's reagent. Formation of Nessler's reagent. When potassium iodide is treated with mercury iodide, we are going to get K2HgI4 dipotassium mercury tetraiodide as a product that is called as Nessler's reagent. When this Nessler's reagent is treated with ammonia in the presence of basic medium like potassium hydroxide, we are going to get iodide of millions base as a product that has a reddish brown color. Along with this, we get potassium iodide and water as a product. Uses and structure of ammonia. Ammonia is mainly used in the manufacture of fertilizers in the form of ammonium nitrate, urea, ammonium phosphate and ammonium sulfate. Along with that, it is used in the preparation of concentrated nitric acid by Ostwald's process, used cooling agent or refrigerant, protophilic and non-aqueous solvent. Protophilic means proton loving in nature. Structure of ammonia. Nitrogen has electronic configuration of 1s2, 2s2, 2px1, 2py1, 2pz1. 2s2, 2px1, 2py1, 2pz1. These four atomic orbitals undergo hybridization to form sp3 hybridized orbitals. Out of 4 sp3 hybridized orbitals, 3 sp3 contains single electron each, where one contains lone pair electron each. So this is the sp3 orbital where you can see lone pair of electrons. So remaining 3 sp3 orbitals, they overlap with the s orbital of hydrogen. Expected shape is tetrahedral, but due to repulsion of lone pair and bond pair, the shape is going to change to pyramidal in nature. Ammonia is expected to have tetrahedral geometry. The central nitrogen atom involves sp3 hybridization, one position occupied by lone pair of electrons. Here you can see that, and 3 bond pairs and 1 lone pair of electron as shown in the structure. Lone pair distorts its geometry and molecule has pyramidal geometry with nitrogen atom at the apex. Nitrogen-hydrogen bond length in this case is 101.7 picometer, whereas hydrogen-nitrogen bond angle is 107.5 degree. Preparation of nitric acid. Laboratory method to prepare nitric acid. In the laboratory, nitric acid is prepared by reaction between sodium nitrate with concentrated sulfuric acid. We are going to get sodium hydrogen sulfate along with the nitric acid as a product. Preparation of nitric acid on large scale or industrial method of preparation of nitric acid by Ostwald's process. Students, this preparation is very important. They are going to ask this for 3 marks. So this preparation involves 3 balanced chemical equations. You need to learn these 3 balanced chemical equations compulsory. It involves the following steps. The first one, oxidation of ammonia with air or oxygen in the presence of platinum rhodium catalyst at a temperature of 500 Kelvin and 9 bar pressure to form nitrogen monoxide as a product along with water. In the second step, This nitrogen monoxide undergoes further oxidation to form nitrogen dioxide, and this reaction is reversible in nature. In the third step, this nitrogen dioxide is dissolved in water to form nitric acid as a product along with nitrogen monoxide. The nitrogen monoxide thus formed in the third step is once again used as a reactant in the second step to get nitrogen dioxide as the product. Structure of nitric acid. Nitric acid has a planar structure as shown in this diagram, and in the case of nitrogen, oxygen bond angle is 130 degree, whereas nitrogen bond angle is found to be 102 degree. Nitric acid is a planar molecule. Bond length between hydrogen and oxygen is 96 picometer, whereas oxygen nitrogen bond length is 140.6 picometers. Bond angle hydrogen oxygen nitrogen is found to be 102 degree, whereas bond angle between oxygen oxygen is found to be 130 degree. Reactions of nitric acid. The first one with the copper. Remember students, when the metal reacts with acid, we are going to get metal salt as the product. Copper reacts with nitric acid, dilute nitric acid here in this case, and we are going to get product cupric nitrate along with nitrogen monoxide or nitric oxide and water. When copper reacts with concentrated nitric acid, we are going to get cupric nitrate as a product along with nitrogen dioxide and water. Students, remember the products of nitrogen in these two reactions, they ask in competitive exam. When copper reacts with dilute nitric acid, we get nitric oxide or nitrogen monoxide as a product. When copper reacts with concentrated nitric acid, we get nitrogen dioxide as the product. Reactions of nitric acid with zinc. When nitric acid reacts with zinc, we are going to get zinc nitrate and N2O, nitrous oxide, or also called as laughing gas, along with water. When zinc reacts with concentrated nitric acid, we are going to get zinc nitrate, nitrogen dioxide and water as the product. So once again, remember, when zinc reacts with the dilute nitric acid, the oxide of nitrogen is a nitrous oxide, that is laughing gas. When zinc reacts with concentrated nitric acid, the product is going to be nitrogen dioxide. Reaction of nitric acid with phosphorus. When acid reacts with the non-metal, we are going to get acid as the product. Phosphorus reacts with the concentrated nitric acid to form orthophosphoric acid as the product along with nitrogen dioxide and water. With iodine. When concentrated nitric acid reacts with the iodine, we are going to get iodic acid as a product along with nitrogen dioxide and water. Reaction of nitric acid with sulfur. When concentrated nitric acid reacts with the sulfur, it forms sulfuric acid as a product along with the nitrogen dioxide and water. When nitric acid reacts with the carbon, we are going to get carbon dioxide, nitrogen dioxide and water as the product. Action of nitric acid on gold and platinum. Nitric acid reacts with HCl and forms a compound called by the name aqua regia. This e-Gyan is capable of dissolving noble metals like gold and platinum. So when these two reacts, they form nitrosyl chloride, water and nascent chlorine. That nascent chlorine reacts with the gold to form complex tetrachloroarate. Similarly, platinum reacts with that nascent chlorine. Nascent chlorine indicates the chlorine formed in reaction mixture. And similarly, it gives chloroplatinic acid. Reaction of concentrated nitric acid with benzene. When benzene reacts with the concentrated nitric acid, we are going to get nitrobenzene as the product. And this reaction takes place in the presence of concentrated sulfuric acid. Hence, the mixture of concentrated sulfuric acid and concentrated nitric acid is called as nitrating mixture. So here we get nitrobenzene along with water. This reaction is called nitration. Similarly, when toluene reacts with the concentrated nitric acid and concentrated sulfuric acid mixture, we are going to get 2,4,6 trinitrotoluene as the product. Action of concentrated nitric acid on phenol. When phenol undergoes nitration with concentrated nitric acid and concentrated sulfuric acid, we are going to get 2,4,6 trinitrophenol along with water with cane sugar. When sucrose or cane sugar reacts with the concentrated nitric acid that act as even oxidizing agent, it oxidizes this cane sugar to oxalic acid and water. Brown ring test. Nitrate ion from the nitrate salts, when it is treated with ferrous sulfate in the presence of concentrated sulfuric acid, we are going to get nitrogen monoxide, ferric ion and water. This nitrogen monoxide further reacts with the hexaqua iron 2 to form a brown ringed complex as shown in the following diagram. So here you can see there is a formation of brown ring. So in brown ring, this NO is present in +1 oxidation state, and if you calculate the oxidation state of iron, students, it is going to be +1. Thank you, students.